Yeah, this is actually basically what that's going on in a black box. And so if you put sugar in, for every carbon of sugar you put into a cell, you also need to then consider that you need 0.22 units of nitrogen. Otherwise, the cell can't grow. Then, yeah, you can just as well introduce less sugar. When we're talking about lactobacillus, so for every organism that's different. But, yeah, you can also from these formulas you can derive how much product you would expect. So if your product is some kind of sugar or some kind of lipid, it can never exceed these levels if you don't change the other levels. So that's why it's valuable information. And these ratios are kind of fixed. So that's what stoichiometry is about. All these ratios and how you can influence them. But you can also reduce this to an even simpler level. So I took one example more, and it's a pity that Martin is not here. Because I thought, well, he's working with penicillinum roqueforti. And this would then be the arrow is the black box for the roqueforti, and the C3H5O3, that is lactate. So what the milk, the lactobacillus produces, is eaten by this fungus. And the only thing the fungus does, like technically speaking, is taking, for each molecule of lactate, it takes 3 molecules of oxygen, 1 proton, and produces 3 CO2 and 3 pieces of water out of that. That's basically what the cell does, and of course it produces cells while it's doing that. But chemically speaking, this is the.
You said that it produces time cycles. Where is the time cycle?
Yeah, those are byproducts. So those are this is like the main process that's going on in that cell from a factory kind of point of view, from a black box kind of view. This is what it's all about. This is what drives the cell, if you want to know how fast the cell is doing this, then you could simply measure the acidity of the liquid, because for every lactate it takes away the acidity drops, or the pH rises. So if you would take a piece of pH paper and measure it every half an hour, or maybe you have a digital sensor and measure it continuously, you can nicely monitor the production of toxins or production of biomass just based on this formula, because you know how fast it is converting stuff based on the acid it consumes. Lactic acid is an acid. So you can, in this case, you can use the acidity as an indicator.